Article 460.1 addresses the installation and use of capacitors and capacitor assemblies specifically for improving the power factor of electrical systems. However, it excludes surge capacitors or capacitors included as a component part of other apparatus and conforming with the requirements of such apparatus. Article 460.2 defines surge capacitors as capacitors used to protect electrical equipment from transient overvoltage conditions. Medium voltage power factor correction capacitors are not surge capacitors. Therefore, medium voltage power factor correction capacitors are not excluded from the requirements of Article 460. The 3-gallon dielectric fluid limit in Article 460.2c applies to these capacitors. Consider a situation where a client specification requires compliance with NEC Article 460 and dictates an indoor installation with less than 3 gallons of dielectric fluid for each capacitor. If the equipment contains 6 capacitors, each holding 3.3 gallons of fluid, the total fluid volume would be 19.8 gallons. This setup would not meet the client specification as written. To achieve compliance with the client specification, consider these options. Firstly, reduce the number of capacitors used in the system to maintain the total dielectric fluid volume below 3 gallons. Secondly, consider installing the equipment outdoors, as Article 460.2c applies only to indoor installations. Thirdly, obtain a variance from the authority having jurisdiction, which allows the installation of equipment with more than 3 gallons of dielectric fluid indoors. It is recommended to discuss these options with the client to determine the most practical and cost-effective solution that aligns with their requirements. This interpretation clarifies the application of NEC Article 460, particularly regarding power factor correction capacitors and their dielectric fluid limits, helping to navigate compliance challenges in electrical installations. When dealing with power factor correction capacitors, it's essential to thoroughly understand the National Electrical Code, specifically Article 460, to ensure compliance and safety. These capacitors are used to improve the power factor in electrical systems, making them more efficient. However, their installation and use are subject to certain regulations, especially concerning the type and amount of dielectric fluid they contain. Let's delve deeper into Article 460 and its implications for your specific situation. Article 460.1, which defines the scope of this code section, covers the installation and use of capacitors and capacitor assemblies designed to enhance the power factor of electrical systems. It's crucial to note that the scope does not include surge capacitors or capacitors that are integral components of other apparatus, provided these components conform to the requirements applicable to those apparatus. Surge capacitors, as defined in Article 460.2, are used to protect electrical equipment from transient overvoltage conditions. These are distinct from power factor correction capacitors, which aim to improve the efficiency of the electrical system by reducing reactive power. The distinction is important because the requirements for surge capacitors may differ from those for power factor correction capacitors. Article 460.2c addresses the dielectric fluid limitations for indoor installations. It specifies that indoor installations must not contain more than 3 gallons of flammable dielectric fluid in any capacitor. This limitation is primarily concerned with fire safety and the potential hazards associated with flammable liquids in enclosed spaces. Therefore, it is essential to comply with this requirement to ensure the safety of the installation and personnel. Now let's apply these interpretations to your specific situation. You're using 6 capacitors, each containing 3.3 gallons of dielectric fluid within a metal enclosed enclosure for indoor service. This configuration does not comply with the 3-gallon limit per capacitor for indoor installations, as each capacitor exceeds the allowable amount. Consequently, your equipment does not meet the client specification as it is currently designed. To achieve compliance, several options are available. Firstly, you could reduce the number of capacitors used in your system. By decreasing the number of capacitors, you can ensure that the total amount of dielectric fluid remains below the 3-gallon limit per capacitor. This may involve redesigning the system or selecting capacitors with a lower fluid capacity. Secondly, consider relocating the equipment outdoors. Article 460.2c's limitation on dielectric fluid applies only to indoor installations. If the equipment is installed outdoors, the 3-gallon limit does not apply, providing more flexibility in capacitor selection and system design. Thirdly, you might explore the possibility of obtaining a variance from the authority having jurisdiction, often abbreviated as AHJ. A variance is an exception to the code granted by the local electrical inspector or governing body. To obtain a variance, you would need to demonstrate that the installation meets an acceptable level of safety, even though it does not strictly comply with the code. This demonstration might involve providing additional safety measures such as enhanced fire suppression systems or improved ventilation. When deciding which option to pursue, it is crucial to consider both the practical and cost-effective aspects. Reducing the number of capacitors may require a significant redesign of the system, while relocating the equipment outdoors may not be feasible due to environmental or logistical constraints. Obtaining a variance can be time-consuming and may not be guaranteed, but it could offer the most cost-effective solution if successful. Before making any changes, it's recommended to discuss these options with your client to determine the best course of action. The client's input is essential, as they may have specific requirements or preferences that influence the decision-making process. Collaboration with the client ensures that the final solution meets their needs while also complying with the NEC. When designing and installing power factor correction systems, consider these additional factors. Firstly, always follow the manufacturer's recommendations for installation and maintenance. The manufacturer's guidelines provide valuable information on proper installation techniques, wiring requirements, and maintenance schedules. Adhering to these recommendations can help prevent premature failure and ensure the system operates efficiently. Secondly, ensure that the capacitors are properly protected from overcurrent and overvoltage conditions. Capacitors are sensitive to voltage and current fluctuations, which can damage or destroy them. Overcurrent protection can be achieved using fuses or circuit breakers, while overvoltage protection can be provided by surge arresters. Thirdly, regularly inspect the capacitors for signs of damage or deterioration. Routine inspections can help identify potential problems before they lead to failure. Look for signs such as bulging cases, leaks, or discoloration, which may indicate internal damage. Furthermore, consider the environmental conditions in which the capacitors will operate. Extreme temperatures, humidity, and corrosive atmospheres can all affect the lifespan and performance of capacitors. Select capacitors that are designed to withstand the specific environmental conditions present in the installation location. Also, ensure that the capacitors are properly ventilated to prevent overheating. Overheating can significantly reduce the lifespan of capacitors and may even lead to catastrophic failure. Proper ventilation helps dissipate heat and maintain the capacitors within their operating temperature range. Finally, keep accurate records of all installations, inspections, and maintenance activities. These records can be valuable for troubleshooting problems, tracking performance, and ensuring compliance with regulatory requirements. Accurate documentation also provides a valuable history of the system, which can be useful for future upgrades or modifications. In summary, adhering to NEC Article 460, understanding the client's specifications, and considering the practical and cost-effective aspects of the installation are crucial for ensuring compliance and safety when working with power factor correction capacitors. By following these guidelines, you can create an efficient and reliable power factor correction system that meets the needs of your client while also complying with all applicable regulations. Remember, consulting with a qualified electrical engineer or inspector can provide valuable insights and guidance throughout the design and installation process. Their expertise can help ensure that the system is designed and installed correctly, minimizing the risk of problems and maximizing its performance.